Ignition sequence start.
Good morning and welcome to Mission Control Houston. You're looking at the International Space Station Flight Control Room, members of the Orbit 2 team of flight controllers, as they keep tabs on the station's systems while the Expedition 60 crew members finish up another busy work week in space. Commander Alexei Ovchinin and his Russian, American, and Italian crewmates focused on station maintenance and science activities this week. But they also spent time keeping their eyes on the big weather story of the year, developing right outside their window.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Gary Jordan. This week, cameras both in the hands of astronauts and mounted outside the International Space Station were trained on Hurricane Dorian. The powerful storm was seen clearly from 250 miles above the Earth throughout its path this week, affecting the Bahamas and the southeastern United States as it made its way north. Live video was captured as the space station passed right overhead, and NASA astronauts shared photos of their perspective of the massive hurricane. Views of storms from the space station could provide valuable data about the life cycle of hurricanes. An uncrewed Soyuz spacecraft is set to undock from the International Space Station after its short stay aboard. After just 11 days aboard the orbiting laboratory, the Soyuz MS-14 is set to undock and return to Earth for a parachute-assisted landing in Kazakhstan. Inside will be Russian cargo and an experimental humanoid robot, Skybot F-850. Watch the craft undock from the station live on NASA TV. No views will be provided for the uncrewed vehicle's landing. This week's question comes from Chinthi Bro, who asks about the space station's internet connection speed. Well, it's a lot faster now thanks to a recent upgrade. The space station communicates with Earth through radio frequency signals using a system of tracking and data relay satellites stationed in geosynchronous orbit and ground-based antennas that are part of the space network. NASA recently upgraded software, data processors, routers, data lines, and more to increase the data rate to 600 megabits per second, effectively double of what was previously possible. Access to the internet is a small fraction of this capability, as its primary use is transmitting data for operating the space station systems and for collecting valuable scientific data. Just this week, it was used for plant growth experiments, 360-degree video, and much more. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
As we mentioned there, NASA TV and NASA.gov will have live coverage of the undocking of the 60 Soyuz spacecraft from the International Space Station, coverage starting at 12:45 Houston time this afternoon, the undocking scheduled for 1:13. We will not have live coverage of the spacecraft's landing in Kazakhstan, but that should happen about 4:35 Houston time this afternoon. 59 Soyuz, the last Soyuz spacecraft that brought people to the space station, delivered cosmonaut Alexander Skvortsov for his third long-duration mission, European Space Agency astronaut Luca Parmitano of Italy for his second, and NASA's Drew Morgan. Morgan's first launch to space did happen on the 50th anniversary of the first landing of human beings on the moon. But he's no stranger to making giant leaps.
I think I often describe myself as a soldier, a physician, and an astronaut. The pursuit of those happened in that order. And one of the earliest memories I have is of always wanting to be in the military, of wanting to be a soldier. Quite a history of military service in our family. Both of my grandparents, my father was an Air Force officer, and I also remember my parents telling me a story about my great-uncle Clink, Harry McClintock, who was a paratrooper in World War II. He was in the 101st Airborne Division and jumped at Normandy on D-Day, and then jumped in Operation Market Garden in Holland. And that was the first time I had ever heard of the concept of a paratrooper or what it meant to be an airborne soldier. So when I later decided, I graduated from high school and I went to West Point, I knew that I was very interested in this concept of being an airborne soldier. At West Point, they had a parachute team called the Black Knights. Yeah, so I made the parachute team, and that became one of the central activities of my remaining 3.5 years at West Point. In addition to academics, after class, we jumped most days of the week, but then we were also a demonstration team, so we jumped in football games. Also, while I was a cadet, I went through military basic airborne course, which taught military static line parachuting. Specifically the parachute aspect of it, if I go back to the time when I was a cadet, my teammates that I was selected with became my best friends in the world and continue to be to this day. And that camaraderie that we had and that dependency we had on each other, making sure that we were skilled in the aircraft, skilled in the air, our lives depended on each other to do safety checks of each other, that type of camaraderie is something that I feel now in the astronaut corps with my astronaut colleagues as well. I think about how 20 years ago I was developing those skills at an early age and didn't even know it. I'm Andrew Morgan, and I'm a soldier, a physician, and an astronaut.
The International Space Station is a laboratory in space where scientists can do research in a variety of scientific disciplines and remove the constant of gravity from the equation in ways they just can't do on Earth. In natural sciences, this is especially useful. For instance, in finding out how surface tension and capillary flow can be harnessed to move fluids in more efficient ways. What might look like somebody just having fun can also improve systems for moving fluids in microgravity, like, moving propellants in fuel tanks during space travel? International Space Station crew members are the test subjects in some of the research in space, as scientists discover and investigate, how being in space impacts human health. That includes studying how the crew members establish a routine for sleep, which is a key to their being able to function to the best of their ability. In this demonstration video, astronaut Ricky Arnold talks about the problems with sleep in space and how the astronauts overcome them.
Hi, my name is Ricky Arnold on the International Space Station. We get asked a lot, how do we sleep in space? And it's a great question because we all know how important a good night's sleep is. If you're not getting a good night's sleep, you can count on reduced cognitive function, poorer reaction times, and maybe just being a little grumpy. And up here in space, just like on Earth, those are things we all want to avoid. So, we go around the Earth about every 90 minutes, which means we get 16 sunrises and sunsets a day. So how we sleep is a really good question because the sun's always getting ready to come up or it's getting ready to set. And we use those cues on Earth to let us know when it's time to begin our day and when it's time to end our day.
Ricky is talking about circadian rhythm. It's the body's natural regulator for sleep and wake cycles based on a 24-hour schedule. Those 16 sunrises and sunsets he mentioned can cause circadian misalignment and sleep deficiencies during long-duration spaceflight. The hazards of lost sleep can range from poor attention at school to on-the-job errors to long-term sleep loss, even chronic disease. Sleep is super important. Hey Ricky, what are you doing on the space station to get some sleep?
Well, here in space, we kind of have to do it artificially. So we have these nice crew quarters. It's about the size of a refrigerator. It's very quiet. The space station can be a little noisy, but it's very quiet in here. And we can control light with a light switch. If we are just middle of the day, we have a light like you're seeing right now, which is just this kind of standard lighting. It's getting close to the end of the evening. You want to dim the light a little bit, kind of for the end of the evening. Or if you're going to be up late and you need to keep awake, we have a really bright light setting. The other thing we have is off. You see how dark it got. Another challenge sleeping on the International Space Station, sleeping in microgravity is really nice because you can just float and stretch out and it's really comfortable. The problem is with the air currents in the International Space Station, you could very well float into a piece of hardware and hit your head, or worse yet, even break something. So we got our sleeping bag here, just almost like a sleeping bag on Earth. But as you can see, we have bungee cords that help hold us up against the wall, so I almost sleep standing up. And also, I do have a pillow. It's just a bag full of clothes, but I actually keep it up on the top of my head because I'm a little tall. In the crew quarters, I tend to hit my head on the ceiling when I'm sleeping. So I got my sleeping bag here. I got my bungee cords to hold me in. And then when it's time to go to bed, it's quite easy. Just unzip the sleeping bag, climb on under the bungee cord, climb into the sleeping bag, make sure you're nice and secure, zip yourself up, plan on getting a good night's sleep so I have good reaction times, my cognitive ability is what it should be, and that I'm not grumpy in the morning. So with that, I'm all set. Good night from the ISS.
Studying the International Space Station crew members to learn about how human bodies respond to the alien environment of weightlessness is one aspect of the scientific journey on the space station. Another important aspect of the station's contribution to education is that it provides a place to conduct experiments that are devised by students. Now, both of those aspects were combined for the Genes in Space competition, which challenged students and teachers across the country to design and fly an experiment about the relationship between altered DNA and the weakened immune systems that some astronauts experience during spaceflight. Anna Sofia Bogoraev's experiment was up to that challenge.
When I was 4, I told my mother I was going to be an astronaut, so it's kind of been a perpetual thing from there. And I figure if I'm going to be an astronaut, I don't want to be getting sick. And if someone isn't doing what I think about the immune system, why don't I go look at it myself? This is the mini PCR machine designed by Mini PCR. PCR is polymerase chain reaction, so DNA amplification. We now have more DNA amplification capabilities on the station, but when this went up, it was the first.
Hi, this is Tim Peake on board the International Space Station, and this is a message to Anna Sofia to say a huge congratulations for your winning submission to investigate the effects of cosmic radiation and microgravity on the body's immune system.
So you're meant to have a balanced ratio of your T helper 1 and T helper 2 cells, but when you're in space, you get a much more dominant T helper 2 phenotype, which decreases your cell-mediated immunity and just generally hampers your immune system.
The space travelers of today and those of tomorrow have at least one thing in common with the explorers of old. They are all at the mercy of the weather. The astronauts and the systems of their future space vehicles will have to be protected from the radiation of deep space. That's why today's scientists are working hard to improve our ability to accurately forecast dangerous space weather.
The space we travel through. Presented by Science at NASA. When seafaring nations began to explore new regions of the world, one of their biggest concerns in making the journey safely was how to cope with weather. They could harness the wind for power. They could rely on the sun and the stars for navigation. They could build sturdy ships. But if a storm rose suddenly, they were at nature's mercy. More than 5 centuries later, our nation is once again on the cusp of exploring new worlds. And once again, one of our concerns about traveling long distances is the weather, space weather. While space is a vacuum, it's not 100% empty. Particles, energy, and magnetic fields travel through the void. Much of these emanate from the sun's corona, as part of a constant outward flow known as the solar wind, which stretches well beyond the orbit of Neptune. There are also high-energy particles or cosmic rays in the mix, which travel vast distances from dying stars or supernovae. Earth's magnetic field and relatively thick atmosphere act as a shield against the most harmful forms of this radiation, but in space, there is no such deterrent. If we want to travel through this space, we need ways to protect our astronauts. These particles can affect our technology, tripping onboard electronics. Dr. Yari Calatavega, space weather scientist at NASA's Goddard Space Flight Center, notes, "We are working hard to forecast when these particles will be at their peak, such as during solar flares or coronal mass ejections. Acute exposure to these solar energetic particles is a serious concern for astronauts and instruments. Therefore, having a better understanding of when to expect solar activity is important for safely sending our astronauts and spacecraft through space. Ironically, such space weather activity can actually protect against another threat to astronauts. The sun's activity can block dangerous cosmic rays coming from other stars, which are constantly present, illustrating the complexity of the system NASA tries to understand and mitigate for our space travelers. Over time, sea captains learned when to sail their ships and when to stay in harbor, based on their accumulated knowledge of the weather. It's more risky to be on the water in the Caribbean during hurricane season, and you'd want to consider avoiding the northeast coast of America during the height of winter. Dr. Calatavega says, "It's very similar to what we're doing today. We're constantly developing and testing new models to predict space weather, and we're constantly seeking new data to refine those models. A host of heliophysics missions observe space from a variety of vantage points, not unlike terrestrial weather sensors, which work in tandem to paint a bigger picture of our space environment. In August 2018, NASA launched the Parker Solar Probe to help us better understand the sun's activity, especially what drives the solar wind and how energetic particles get accelerated. This data could be used to improve models of space weather forecasting, ultimately helping us find new and better ways to shield our spacecraft and protect our astronauts. Whether it was the oceans ancient ships traveled through, or the space we will one day travel through, we know this: keeping a watchful eye on the environment around us is key to ensuring safe passage. For more information about what matters in space, visit science.nasa.gov.
Studying the space environment is just a part of the overall effort of space exploration. NASA's Artemis program right now is developing the hardware that will be needed to take astronauts back to the moon by 2024 and then later into deep space. Here's a breakdown of the elements of NASA's plans for moving out beyond low Earth orbit.
So you want to go to Mars. How do we send humans to deep space? In order for humans to explore the moon, Mars, and beyond, we need safe, flexible, and powerful systems that will make it all possible. We start with the world's largest spaceport. At Kennedy's Space Center, we have all the buildings and tools needed to assemble and launch space vehicles, and have the teams in place to recover the astronauts when they come home to Earth. Next up, we need a deep space rocket. This is NASA's Space Launch System. It will be the most powerful rocket NASA has ever built, and it has the muscle to lift people and all of the equipment needed for missions to new worlds. The Space Launch System will blast off with the crew in the Orion spacecraft. The most advanced spacecraft ever built for human exploration, Orion provides the life support, power, communications, and other systems to safely transport astronauts on a variety of exploration missions, like to the moon. In lunar orbit, we will learn to live and work in a deep space environment, something we have never done before. In future missions, NASA's Gateway will be a place for astronauts to live, work, and prepare for missions deeper into the solar system. There you have it. NASA's Deep Space Exploration Systems, charting our new future in space. To find out more about deep space exploration, visit this NASA website.
At the top of the show, we told you about the International Space Station crew members using their vantage point to provide important imagery of a current weather emergency, Hurricane Dorian. Well, the truth is, most crew members spend some time of their time on orbit looking down at the Earth and taking pictures. On his most recent mission, astronaut Jeff Williams aimed an ultra-high-definition video camera at the planet. After he got home, we asked him to share some of those images and talk about the beauty of the planet, the variety of things to see, and the value of sharing that perspective with everyone who can't go to orbit in person.
I don't remember exactly where we were the first time I viewed the Earth, but I remember getting out of the spacesuits in the middeck of the space shuttle and then floating back up and then having a chance to actually get my full view out the window, to get close to the window and to view the Earth. And what struck me was just the overall beauty of the planet, and specifically with the blues of the oceans and the whites of the cloud formation. I put a high priority on photography and video out the window of the Earth. You see things at a different scale, and I think you can grow in your appreciation for what the Earth has to offer to support our livelihood, to support civilizations. And now we can see it in a global scale and maybe grow in our appreciation of those things that are unique to Earth. To view the Earth from space, of course, especially from a photographer's point of view, it's a target-rich environment. The ocean currents and the vastness of the oceans, and in particular in sun glint, the cloud formations and other weather patterns are a never-ending variety. The different landforms that you have show themselves in different ways. Forested areas are much different than plains. Agriculture stands out. You can see elements of the culture and the history of the area just through the patterns of agriculture. Sand dunes became one of my favorite things to take pictures of. You also have the evidence of civilization and habitation on the Earth. Every sunset, every sunrise is unique especially in its patterns of cloud formations that the sun sets or rises from behind. When you finish and you're back on the Earth, the memories diminish quickly. So to capture the memories, to be able to bring back the experience to others and viewing this planet, now we can see it in a global scale and maybe grow in our appreciation of those things that are unique to Earth.
If you'd like to get another look at any of the stories we featured today, you can. Check us out on YouTube and Facebook. Here are the addresses. And while you go there, look around because there's lots of other cool stuff you'll also find about NASA and America's human spaceflight program. Since you're out on the internet anyway, why not check out Houston, We Have a Podcast? Folks here at NASA talking about their work in many aspects of space exploration. We post new episodes every Friday. Today, Dan Hewitt gets the basics on the Boeing Starliner, one of the new commercial crew vehicles being developed to fly to the International Space Station, in a talk with Boeing engineers Tony Castilla and Selena Dopart. Go to nasa.gov/podcasts for today's episode. All of our previous episodes are there as well. So is the full library of all NASA podcasts. All of them also available to you on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.